Hello and welcome to today's video. Today we're going to be talking about changes of state. So an example where we have a change of state could be when ice, a solid, melts into water, a liquid. So here we have a solid going to a liquid, and that is a change of state. So to carry on our discussion, I'm going to introduce the specific latent heat, which is a quantity which we label by a capital L. And specific latent heat is just the energy required to change the state of a substance. So we know that any substance is made up of atoms and molecules that are held together by bonds. To melt a solid, or, for example, to boil a liquid and evaporate it, we need to supply energy to break these bonds that hold the particles in place. The amount of energy that we need to supply to break these bonds or form these bonds in order to change the state of a substance is given by this equation here. And it's very important to note that this energy we're supplying for this specific equation is the energy supplied to change the state of the substance in question. But this does not mean a change in temperature. It is simply the energy we need to supply to break or form the bonds to change the state, not the energy needed to change the temperature. So, there are two different types of latent heat you need to know: latent heat of fusion and latent heat of vaporization. So latent heat of fusion is for any instance where we're talking about a solid to a liquid, that transformation of change of state there. And latent heat of vaporization is for when we have any sort of liquid to vapor. Okay, so if we look at the diagram that I've drawn here, we can see a temperature against internal energy graph. And this is for water to vapour, so liquid to vapour. Initially, as we supply heat energy to the water, we can see an increase in temperature. We can see at 100 degrees Celsius, there is a change of state, and that's represented by the horizontal part of the line. During this change of state, the kinetic energy of the particles stays the same, and the temperature stays the same. But it's in breaking the bonds that the potential energy of the particle increases, and this means the internal energy of the particle also increases. And after this change of state, we now have water vapour. Okay, now let's look at a quick example. How much energy is needed to freeze 250 grams of water from 0 degrees Celsius? So first of all, we need to have a look at what the important parts of the question are. So we're looking at freezing, and 250 grams is our mass. So we're given the latent heat of fusion and the latent heat of vaporization, but which one are we going to use? Well, since we're talking about a solid and a liquid, we're going to be using fusion. So 334 kilojoules per kilogram. Okay, so the next thing we need to do is write down our equation. And if you remember from earlier, that's E equals mL, and our L in this case is LF because it's latent heat of fusion. Now we need to remember that our mass should be in kilograms. So let's divide 250 by 1,000 to get 0.25 kilograms. Now if we pop the information into our equation, that's 0.25 kilograms times by 334,000, because we're given in kilojoules, we need to turn this into just joules, so times by 1,000. And then if we put this into our calculator, we should get an answer of 83,500 joules. Thank you for watching to the end of the video. I hope it's helped.